Hello mathematicians, thank you for joining me again today as we try to find the antiderivative of 2x cubed minus 3 over x squared minus 1 over x plus sine of x dx. So we want to find all antiderivatives or the indefinite integral. So now as we do this, remember that the goal is to find functions whose derivative is equal to the original function. And then if we can find one, we can find all by adding a constant of integration c. Now what we've learned is that instead of trying to do this all at once, we can break it up into smaller pieces. So that's what we're going to do. The first thing we know that we can do is we can distribute an integral across sums and differences. So this indefinite integral is going to be the integral of 2x cubed dx. Remember the integral and the dx are connected because it's telling us what to integrate with respect to. And then we get minus the integral of 3 over x squared dx minus the integral of 1 over x dx plus the integral of sine of x dx. Now the next thing we can do to help ourselves out is that we can factor constants out of integrals just like we could for derivatives. So we get 2 times the integral of x cubed dx minus 3 times the integral of 1 over x squared dx minus the integral of 1 over x dx plus the integral of sine of x dx. So now as we look at this portion here, we've simplified this so that it's much easier to deal with, and so we want to find a function whose derivative is x cubed. Now if we remember, our power rule for derivatives is if we took a derivative of a power function, we would subtract 1 from the exponent and multiply by the original exponent. So what I want to think about here is, well, if I'm going to subtract 1, I should probably add 1. And so I'm going to actually guess that the integral of x cubed dx is going to be x to the 4th. But now I should actually check my work. So if I take the derivative of x to the 4th, what I get is 4x cubed. So notice that I'm off by a factor of 4 if I'm looking for x cubed. So what I can do here though is that because you can factor constants out of derivatives, is if I multiply by 1/4, that 1/4 will carry through, and then the 1/4 and the 4 cancels, and so what I get is an antiderivative of x cubed is x to the 4th over 4, because the derivative of x to the 4th over 4 is indeed x cubed. Now, you can also do this for any power function and say the antiderivative of x to the n is, well, I should add 1, but then I'm going to be off by a factor of n plus 1, so therefore I should divide by n plus 1. And so in general, we're going to get the integral of x to the n is just x to the n plus 1 over n plus 1. Now if I continue with this problem, the next thing I want to do is I'm going to use that same power rule on this one, except for I have to rewrite it as a power function. So instead of 1 over x squared, I'm going to write it as x to the negative 2. Now if I continue with this, I'm just going to bring this down, 2x to the 4th over 4 minus 3 times, and now if I add 1 to this exponent, x to the negative 2 plus 1 is negative 1, divided by the new exponent is negative 1, I get negative 3 times x to the negative 1 over negative 1. Now, if I move on, I want to find the integral of 1 over x. Well, notice if I try to turn this into a power function, I get x to the negative 1. And if I try to use my power rule, I get x to the negative 1 plus 1 is 0, so x to the 0 divided by 0. And so if I just look at x to the 0 over 0, notice that that's not going to be a defined function because I can't divide by 0. So in this case, I can't use the power rule, but what I have to do is I have to think about what function has a derivative of 1 over x. And in particular, what we know is that actually the derivative of natural log of x is 1 over x. And so I want to point out here that the domain of natural log is x greater than 0, whereas the domain of 1 over x is x not equal to 0. So in order to get the domains to line up, we actually have to take the natural log of the absolute value of x. So the antiderivative or an antiderivative of 1 over x is negative natural log of x. And so I'll just carry that one down so that we're on the same line. The next thing we need to do is find a function whose derivative is sine of x. So if I think about sine of x, I would think the derivative would be cosine, and if I take the derivative of cosine, I get out negative sine. So I'm off by a negative number, so if I want to find the integral of cosine, I should divide by the negative 1, and so I would say that the antiderivative is negative cosine of x. So if I check, the derivative of negative cosine of x is negative sine of x is positive sine of x, so we have indeed found an antiderivative of sine of x. Now I do want to point out here that we found one antiderivative, whereas we wanted to find all antiderivatives. So therefore, if we want to find all antiderivatives, all we need to do is say, well, we can find all antiderivatives by adding in a constant of integration. So at the end here, now that we're done with all of our integration, we're going to put a plus c here at the end. Thank you for watching. As always, I hope you learned something today, and I hope you enjoyed the process along the way. If you did, make sure to like the video and subscribe to the channel. It helps me to know which videos are helpful, and it helps other people to find these videos so that they can also get help. Thank you.